In this video, we continue our discussion about design patterns. And in this section, we're going to focus on the structural design patterns. So the section for structural patterns is right here, slide number 23. So basically, we discussed the possibility of various classes in the structure of the building elevator simulation program. So those many of these classes we already discussed. So the structural patterns sort of clarify and improve the ideas behind both the abstract concepts of our classes as well as their implementation. So they do a lot of clarification when we rely on certain well-known structural patterns. And we're also going to clarify that we can have multiple interfaces in the system and clarify their need because we can validate it by a certain design pattern. We also can improve and find better ways to use computer memory by applying certain patterns and expecting certain benefits from these patterns. So the first of the structural patterns that I'd like to discuss is a proxy design pattern. So I'm navigating to section number 40, right here, slide number 40, proxy. So proxy design pattern is pretty flexible. It could address a lot of different interesting problems to solve. So consider an object representing an expensive resource. For instance, it could be like some sort of multimedia file, a large video file or a large image file, which gets processed by our application. So first of all, it could be an expensive resource to load and process. Second of all, it may be impossible to duplicate. You just simply cannot quickly copy a large video file. It will be very expensive to do something like this, in both space-wise and very time-consuming. Some of the things are impossible to duplicate due to the nature of the technology that we're using. For instance, you have a network connection, so you may have to rely on the existence of a specific network connection with your server, and you really don't want to open another connection. So you may want to be able to maintain a unique network connection, and only if you disconnect, then you can reconnect again. As we discussed, a large object, such as, for instance, could be also a result of very expensive and time-consuming database query. And so, therefore, again, you don't want to duplicate this, because if you to duplicate it, you'd probably run again almost the same amount of time repeating this database query. Open file can also not be easily duplicated. So how could we emulate multiple copies of these complex and unique objects? So in other words, the reality is that all of these objects are just unique in the system, but multiple parts of the system want to be able to use them as if they were actual owners of this resource and naturally be able to use this resource in the way they like. So the solution is to use a proxy class that represents indirect reference to these resources. And so we call these concrete resources, and proxy essentially pretends to be a concrete object. Otherwise, proxy, the concrete objects like this will be known as subjects of our proxy. So the proxy actually controls indirect access to another object while exposing the same interface. So could be multiple reasons for something like this. this is a proxy class diagram for our proxy design. So we have some sort of resource in the system that we would like to be able to not to duplicate, for instance, so we can rely on a specific interface. All right, so our actual object implements a certain interface in the system, and the proxy class also implements this interface, but it does not provide implementation. Instead, it delegates every call to this interface to the real object. But then the benefits of this, various benefits of this, is that we can duplicate this proxy very easily, because it's really kind of lightweight object that we can create multiple instances of this class, and they all could be using the same. So we can have multiple instances of proxy, but they all can have access to the actual object, the subject of this proxy. So I guess we need to clarify this with an example. And I am thinking that, for instance, the elevator interface in our system. Let's think about methods that could be exposed by this interface. So I'm just going to think about it, and so one possibility would be to accept a visitor, right? Accept visitor. Another operation could be forget a visitor. So this is to facilitate interaction between passengers of the elevator who are visitors in our system. And also we can have a method named move. Okay, so the elevator has a chance to move. So the elevator needs to update its position, and if it wants to, it can do so when we call move method from the rest of the system. So I'll just make some adjustments to keep it all readable. So this is potentially the interface of the elevator. And we have two types of elevators, the passenger elevator and the freight elevator in the system, so far as we've been trying to design this. So I'm just going to save this file. So when we just starting implementation of this interface for the passenger and freight elevator, everything can be designed in a very clean way. We know how to accept the visitors, we know how to let go our visitors, or otherwise passengers of the elevator, and we also maintain the functionality of the elevator as a service object or vehicle that moves in the elevator shaft in a building. And at the same time, it's possible that we would like to be able to collect statistics about this physical equipment, elevator as an appliance. So we may have a choice to start interfering with implementation that we already created, and start adding all sorts of additional checks for the statistical data collection inside the implementation that we already have written. This obviously will complicate the current design and make it less reliable even, because it could be just overcomplicating originally implemented simple operations, like for instance move. Okay, so what can we do? We can attempt to implement something that we call a measuring proxy. Essentially, we'd like to be able to keep usage statistics of the elevators in our system. So what we can do is that we can create a class named elevator proxy. All right. elevator proxy. And this proxy class will implement the same interface, just like this. So it will keep implementing the elevator interface, accept, forget, and move. Accept visitor, forget visitor, and move the elevator. But at the same time, what it's going to do, when the proxy is created, it's going to be associated with the corresponding, and I'll do it twice right here, and now I have to again rearrange my diagram. So I try this and just select my classes and just try to rearrange them in such way that we keep everything as readable as possible. So something like this might work. Okay. So here, so what we have, let's save this. And so here what we have is that the thinking is, again, that it's possible that instead of letting our elevator bank communicate directly with the passenger elevator and freight elevator, we may try to have our elevator bank use a proxy class. And this proxy class will simply delegate every call, accept, forget, and move over to the corresponding type, the concrete type of class that is controlling this physical appliance. But at the same time, on top of this, the elevator proxy may check the current direction of the elevator, for instance, and find out how many times during attempts to move this elevator changed its direction. Or we can count the distance traveled by the elevator in using some sort of units, maybe how many floors or how many times the doors have been opening and closing. And what is the benefit of this is that we're decoupling the idea of statistical statistical data from the actual implementation of our elevator class. And so what happens is that at some point, this elevator collecting statistics may signal again, like make sort of like, send the information, generate an event to tell the elevator bank that this specific elevator now needs to be taken out of service and placed for the maintenance and service checks. Right? So this can be very effective implementation of ancillary additional tasks associated with our equipment or some other components of the system. So this is an idea that, again, the first choice would be to forget about proxy and do everything inside our initial classes that we were able to design. Or we can implement additional tasks on top of accept, forget, and move inside these operations at the proxy level to collect the statistics and even be able to generate information and notify other parts of the system about additional sort of runtime conditions or things that may be important for the user to see.